Welcome to Machine Learning at Home. In the last lesson, I tried to explain some very basics of CART analysis, classification and regression trees. And in the end of the lesson, I asked a question. So which analysis, linear discriminant or CART, is better for our iris dataset? So let us check it. Again, I will take liberty and just copy-paste the creation of training and testing subset. So now they're done. And you can do the same, just go to the code of R which specified in the comments of video and then do the same copy pasting. So now we should load both packages. MASS for LDA, RPART for CART analysis, and now we go and do both predictions. I would prefer to do them in a fused way, so slightly more complicated, but one step. So first of all, to distinguish them, we should make some new names like pred.lda will be predict function from LDA model, which will create right here with LDA function, species against everything else, data equal to iris train. And we also need to specify the new data just here. Test without fifth column minus. Okay. This is our prediction for LDA, and very similar will be our prediction for RPART because functions are similarly made. So and then we should use iris test -5, and also don't forget to add a type equal to class, otherwise we'll receive numbers instead of class names. Oh, and of course we should change a name. It will be RPART. Okay. So we now have both predictions, and now we'll create two misclassification tables. So table species variable which wasn't used for the prediction, LDA $class. This is it, and the table for RPART, simply RPART, because we use an option type class. Okay, now we can look on them and visually compare. Actually, LDA worked slightly better. As you see here, 7 Virginicus were misclassified, 6 in RPART case, but in RPART also 2 versicolor are misclassified, whereas in LDA all versicolor were in place. So this is results which are good for the iris data, but not all data sets will work the same way. So remember what I told about CART. It can accept any type of variable, whereas LDA is very picky. It wants variable be measurement, numerical variables, and also requires lots of additional things which many people ignore, but it doesn't cancel these requirements anyway. So CART is much more universal, but it is also has some other minuses, like it's easy to overfit and it's very black and white methods. It's hard to obtain any probabilities for classes except 0 and 1. So choice is yours. You can use either LDA or CART for your type of data. Thank you.